Yeah, I just want to highlight the application of these derivatives. Then you'll be fine. Then we'll go with try questions. We'll still revert to those other methods that we have not yet tried. So, look, how do you find now the marginal cost function? The application of mathematics in economics is what we are trying to do. We want to learn how to find the marginal cost function. Now, what the marginal cost function does, it approximates the change in the actual cost of producing an additional unit. That is what marginal cost does. And so, if you want to find the marginal cost function, given the total cost function, right? You're given a total cost function, maybe it's 2q squared plus 4q. This is the total cost function. If you want the marginal cost shall be the derivative of the total cost function with respect to q. You get it, right? So it will be dtc dq, meaning you are differentiating the total cost function with respect to q. That is how you find
is it the total cost function is equal to 2? This is the formula, sorry. 2.
No, it's not a formula. No. This is not a formula. Like there will be a function, you see the examples. I'm just trying to, you'll be given a total cost. It's just a normal function, maybe 2q squared plus 4q. Yeah, 5. It can be any question, you understand? Just like the way the normal equation, it will be an equation. So now you differentiate that equation with respect to the variable in question, and then you find that's the marginal cost. Okay?
Yes, sir.
Then the marginal average costs. The marginal average cost. What you do is this one. This simply means you have to find the average cost function first. How do you find the average cost? Total cost function is equal to the fixed cost plus a variable cost, isn't it? From microeconomics. Then if you want average cost function shall be equal to the total cost function, which is fixed cost plus variable cost, divided by Q, the output. This will give us what? The average cost function. You get the point, right? Then the marginal average costs. It means that now this average cost function should be differentiated. Okay? You differentiate. You are differentiating the average. So first average function, find it, then you differentiate it, basically. That's the message. Right?
Yes, sir.
Then the marginal revenue function. The marginal revenue function measures the rate of change. Yeah, so what this does, that you are given the total revenue function. If you are given the total revenue function, you derive it or differentiate it. You differentiate it with respect to the variable, maybe Q. You will find the marginal revenue. Have not heard. So to find the marginal revenue function, you differentiate the total revenue function. Then you find the marginal revenue.
The total.
You got it, eh? Revenue function is to be differentiated to find the marginal revenue. This is how we apply math now in economics.
Okay.
Then the marginal profit function, obviously you can guess this one, is to differentiate. You're given the total profit function, differentiate it. When you differentiate the total profit function, the derivative of the total profit function shall give you the marginal profit function. Okay? Any question? No question.
No.
This is the same message that I was saying. So you're given the total function, find the total cost function prime, which is the derivative. Obviously, I explained this when we are doing calculus sign. And then you are given the average cost function. You are seeing it, right? How do you find the average cost function? It's the total cost function divided by output, x, given that x is the output. Then you find that, then you prime this, prime of that, like the derivative of this gives you the marginal average cost. That's the same thing that I've said, actually, if you still remember. Marginal revenue function, you're given a revenue function, you differentiate it, that would be marginal revenue. Profit function is given to you. You're given the profit function, then you differentiate the profit function, right? Derive the profit function, that will give you the marginal profit function, okay?
Yes, sir.
So basically, this is the application of calculus in economics, right? Are there any questions? Yeah, we'll be fine.
Yes, sir.
So having said all these things, then let me lead you to another important part before we start solving the questions. Good teacher must know what is important in teaching. That shows that they know what they are saying. This is now the optimization. Let's do optimization. Optimization is also there in microeconomics, but the most important things that I want you to learn is to determine the maximum and minimum of a function that we are given. Listen carefully. How do you tell that this function has got a maximum value or the minimum value? You get the point, right? When you plot a function, for example, this one. Hello?
I'm getting you,
Hi.
sir. Hello,
When you
I'm
plot
getting.
when
I
you
just
plot a
muted.
function.
I just muted
Oh,
because of the babies. So
okay.
yes, I'm here. I'm getting.
Yeah. So when you plot a function like this, you know how to plot the function. There will be a curve. So if it is curving like this, such that the maximum value, it is like this, it is a positive number like that, then this function is giving us the maximum value. But if, okay, you're not getting it, sir, can you explain like someone who is an expert in these things? Okay. Look, you remember the XY plan? It's like this.
Yes, sir.
Numbers 1, 2, 3, it's going up, right? 1, 2, 3, 4, -1, -2, going, these are X values, negative whatever. You get the point, eh? So what we mean is that when you plot this graph on the XY plane, you find that the maximum value is like this. You get the point? It's curving like this, which means that this function gives us a relative maximum. The y value, like when you go this value, this it is curving or turning at a point. The turning point is at a value that is a maximum. Okay, maximum positive. You get the point, right?
Yes, sir.
But if it is curving like this, giving you a minimum. If it's
Yes.
curving like this, maybe you find the -2 like this. You've seen it. It's a U shape. This will give you a minimum. Like it's a minimum function. Anyways, we'll come back to these. I'm just highlighting the key things that should help you answer the question very well. So now, using the derivatives, the second derivatives, the rule is, here is a rule. The rule is the function shall be relative. Get just these, I wanted you to get this. Shall be a relative maximum, relative maximum if the second derivative is what? Is
Negative.
negative. And this is why higher order calculus I'm talking about, higher order differentials, where you can differentiate. If you remember the first day, I showed you that you can differentiate the function 1, 2, 3, 4, 5, going up what times, number of times, isn't it? The same function. You get the point,
Yes.
right? So when we mean the second derivative, we're talking about differentiating it twice. Differentiate it, again differentiate it. And then you find that if you find it is negative, well and good, it simply means it's a relative what? Maximum. But if you find that it is the
positive,
that's the minimum. You get the point. When is it maximum? Negative.
When it's negative.
Negative. The second derivative. This is a second derivative test. So these are some of the things that
So when you differentiate, you differentiate twice and then the answer is negative, then it's relative maximum.
Yeah.
And then when you differentiate the second derivative and the answer is positive, then it's relative minimum. Okay.
You already know that. Now, assuming that you have a function that you have already differentiated, the function. Let's have the function is equal to this. The function is negative x squared. You've seen it, right? In this function. So what is the y prime? This is the first derivative. It will be negative 2x, isn't it?
Yes.
Now, what is the y prime prime, the second derivative? It will be negative 2, which is less than 0. And so for that reason, we have a relative what? Maximum. Yeah, that's the message. Okay. So if you have the function is x squared, the first derivative is 2x, the second one will be 2, right? Positive.
Yeah.
Which means that we have a what? A relative what? Minimum. At a point, the critical value is x. The critical value is this value where the first derivative is set to 0. For example, the value of x at the point where the first derivative is set to 0. What is the value of x? You divide it through by negative 2. By negative 2, so x is equal to what? To 0. You get the point, right? That's a critical value at that point. You got it, right?
Yes, sir.
Now, teacher should be able to show you the application of this by solving the assignment questions. So we are done with the question 1 up to using this knowledge. Then you can solve question 1 up to question what? Hello? Sorry, I'm not getting. Hello? Is it my line which is cutting? Hello? Hello? Hello, are you back now? Hello? Hi, are you back now? Hello, welcome back to the conversation. Are you back?
Thank you. Yes, I'm back. I think the network just logged me off.
Okay, just a minute. Question number 1 is reading, and I quote in your hearing, you are given a total revenue function. Have you seen? This is a total revenue function. All right. It is 48Q minus CQ squared, isn't it? Hello?
Yes, sir. Yes, sir. Yes.
what would be the critical values of quantities to optimize this revenue function? So to optimize simply means to find the maximum and the minimum. So what would be the critical value? Remember that we want the values of Q now, the values of the variable in that case. Okay. So how do you go about it? Just as I showed you, the first thing, you can find the critical values at the point where the function is optimized, right? To optimize simply means at the point where the function is minimized, the minimum point or the maximum point. Now, to find the minimum or the maximum point of a function, you got to differentiate it. Do the first derivative, right? Do the first derivative of a function. When you do the first derivative, okay, the first differential, you're following, right? You differentiate it once. Then at that point, the function is set equal to 0. You get it, right? And then solve for Q. Did you get what I said? Hey, are you being distracted? Please don't be.
No, I'm saying kindly repeat.
I am saying that for you to find the critical values, first of any function, you got to differentiate the function and then set the derivative of the function equal to 0, right? Differentiate the function, set the derivative thereof equal to what? Equal to 0.
0.
Any questions?
No, so far. You can proceed.
Okay. So
Yeah.
we want to optimize this function. What do? We need to find the marginal revenue. You get it, right? Then that marginal revenue set equal to 0. Then we solve for Q. Simple. So what's the marginal revenue we're differentiating this function? What rule are we going to use here? You can simply use the power rule. What's the marginal revenue function?
So this one is going to be 48.
Which is going to be 48
Q.
minus 2Q. Right. This is the power rule that you need to apply here. You know, you remember the power rule thing. Drop the power, it will be 1 times 48. I guess those things are no longer a challenge to you, isn't it?
Yes.
Yeah, then minus 2 times the 1Q to the power 2 minus 1, you know those things.
Yeah.
48 Q to the power 0 minus 2Q. And then 48 times 1 minus 2Q. These things, that's why I taught them first. I had to begin by teaching them because you are supposed to know them this time. We are applying calculus.
Yes, no,
This is
I
applied.
understand.
You got it, right?
Yes,
Then when
sir.
you set the marginal revenue is set to 0, set equal to what? To 0 both.
So, okay.
You set it equal to 0. So then you solve. So you have 2Q equals to 48, yeah? And then you divide it through by 2, so that Q can be equal to what?
32, 30, sorry, 20, I'm coming this 20. 24.
24. And the answer is C for that math. You choose C. Is this hard?
No. So I think what you said earlier, you have to understand, especially on the fact that you have to understand total revenue, then you differentiate, okay. No, I understand now. Okay. It's clear. It's making sense.
Everything I say is important. You know, when you're old teachers, you just say things that are necessary because you only say what someone will need to use well. So you have to listen.
Yes, sir.
The second question is asking. We are done with question 1.
Mm-hmm.
Second question, question 2. What would be the second order derivative for this total revenue function? Total revenue function is equal to 48Q minus 2Q squared. What will be the second derivative? This simply means you differentiate it for the second time, right? You are deriving it. You're deriving it again. Just
Hello? Hello? Hello?
I am here,
Okay, yes, sir.
right?
Yeah.
Yeah. So I'm saying that we need to differentiate this how many times? Twice. So the first time when you differentiate it, or it's 48Q, right? It will be 48
Yes.
minus 2Q, right?
Yes.
And this will give us imaginary, isn't it?
Mm-hmm.
Then again, we need to differentiate it twice for the second time to find the second derivative, isn't it? What will be the second derivative of this?
Mm-hmm. This one, the second derivative would be, because it would be 0,
Mm-hmm.
0 minus 2.
Yeah, which will be -2, right?
Yes.
And then the second derivative is negative. It is less than 0. It's negative. What does that mean? Is it a maximum? Is it a minimum?
It's a maximum.
Okay. Negative is
Is
a
it?
maximum. Is it
Yes,
what
you
teachers
said.
say?
Yes,
Okay.
the teacher said that when the second derivative is the answer, second derivative answer is negative, then the critical value is it critical value or the
Yeah,
revenue
the critical
at,
value will be
at
at maximum.
maximum? Yes, when it's in positive, then it's minimum.
Okay. Then what is the answer for that matter?
The B.
The answer is B. Okay. But if you find that the derivative is 0, then it is inconclusive. Right? It is inconclusive because it's
Oh,
neither positive nor negative. Get right?
okay. Yeah.
Then the is this hard? No, sir. We are understanding. Your explanation is very clear.
Clear.
Let's go ahead now and look at question number 3. What is it saying?
Question number 3. Kindly just let it goes up a bit. Okay.
Mm-hmm.
All right. Yeah, I can see.
What is it saying?
I read.
Mm-hmm.
Okay, so question 3 says, what would be the total value of revenues at the critical values of quantities evaluated in total revenue is equal to 48Q minus Q squared above?
Very simple.
Mm-hmm.
When the total revenue at the critical values, what are the critical values of this total revenue function?
The critical value that we found is -2. Okay.
That is for the second derivative. I said to find the critical value, differentiate it once, then set it equal to 0.
Oh,
Then you
okay.
prove.
Okay, so our critical value in this case is 48
was 48
minus 2.
minus 2q. Then you derive this. You set it equal to 0 so that 2q is equal to what? 48. So what is the critical value? The critical value is what? 24. That's what we found. So now when the critical value is evaluated into this function, what is the answer? So in short, where there is q, put 24. So it will be 48 times 24 minus 48 squared. They have said evaluated in this function. If they had said evaluated in the first derivative, you could have evaluated it in the first derivative. Yeah? So what do you find now? Punch your calculator.
Okay, let me just get my calculator. So 48 by 24 is 1,152 minus 24 squared.
This is not 24 squared. Yeah, that is
24 squared is 576.
576.
So the answer is 576. Is it?
Can you take the differences?
Yeah, it's 576.
That's the difference. So what is the answer?
The answer is 576.
576. Which is C, yeah?
Yes.
Is this hard? No, sir. The explanation is quite clear.
Yes, it's quite clear. Yeah. It's just that.
And now we have question number 4. You are given the total profit function. Now the profit function has changed. This is a profit function. That one was a Riven function. Q plus 44Q minus 24. What is the first question? What would be the critical values to optimize the function? You differentiate it, you set it equal to 0. That's how you find the critical values. I already explained. So let's do the derivative. What's the derivative of this?
24. So here it will be 2Q.
Negative 2Q.
Yes. Yeah, negative 2Q plus 44. That's all.
Yeah. And so that you can have 2Q is equal to 44. And you divide through by 2, so that Q can be equal to what?
22.
22. What is the answer?
It's 22.
What is the option that you're picking?
Oh, the 2. This is question.
So there is no 22 here among the options. So the answer is none of the above.
Oh.
It's not there, right? None of the above simply means kulibe.
Yeah.
You're good?
Yes.
What would be the second derivative of this profit function? Now I have the profit function. negative q squared plus 44q, 44q minus 24. We want to differentiate this. We want to differentiate it. You know how we find the second derivative, isn't it? The first one is to find the marginal profit, differentiate it first, then again differentiate it. Let's go. What will be the first derivative?
The first derivative, like the one, it would be negative 2q
Plus
plus
44.
44. Then
The second
differentiating
derivative,
again would be negative 2
which is less
plus
than
0.
0.
Yeah.
So, I mean, which one is the answer now?
On question 5, right? So the profit B.
Yeah, it would be maximum at this at the critical value, isn't it?
Yes.
And the critical value is what? What was the critical value?
Critical value in this case is 22.
22, yeah.
Yes.
Yeah. Set this equal to 0. So now, okay, the answer is B. Question 6.
Yeah.
What is it saying?
Question 6 is saying, what would the total value of profits at the critical values of quantities evaluated in total profit function? So total, is it total, that I don't know, is equal to negative q squared plus 44q minus 24 above, like you're saying. So here we are replacing q with
We are substituting.
Yes. Is equal to
negative 22 squared plus 44 times 22 minus 24. And what is the answer?
Okay, let me just do the calculation. So, Sorry, Negative 22 squared, open bracket, plus,
What is 22 squared? Just to do 22 squared.
Okay. So 22 squared is 484.
484, like that. So it will be negative 484.
Then minus 44 times 20.
It's plus. It's plus.
Plus, yeah. 44 times 22, which is 968.
958 minus 24.
968.
So what do you find?
968, sir. Hello?
Hi, what do you find?
I'm saying it's 968, not 958.
Okay, 968.
Yes.
So when you command your calculator, what do you find altogether?
968. So it's 460.
Sorry?
460. The answer
400
is
and
460.
okay,
Mm-hmm.
460.
Mm-hmm.
460. Hmm. Hope we have punched the right thing. Okay.
Yeah, I have. Okay, let me redo. So it's 22 squared. So 22 squared is 484, which is correct. Then
Mhm. Okay.
44
So if you are right, then the answer is what? None of the above, isn't it?
98. Yes. So 968, 968, 84, that minus 24. Yes, it's 460.
So the answer is none of the above,
One of the
isn't it?
above. Yes.
Yeah. Okay. We move on to the higher note of the conversation. You are given the total profit function. This is the total profit function now. Negative 20 q squared plus 144q minus 545. What is the critical values? You know the conversation. What do we do from here? It's boring now. It's slowly getting boring. You've seen it, eh?
It's getting boring.
Camino, we're just saying the same thing again and
It's 20 times 2. So it's negative 40, negative 40 cube. Yeah.
okay.
So this is just,
It's 144.
yeah, minus 144.
It's plus
Oh, it's plus. I wrote minus, sorry. Okay, so it's plus 144, yeah.
so that you can have 40 q equal to
Mm,
144. Divide through by 40
mm,
through by 40 so that q can equal to what?
mm,
144 divided by 40.
mm, 3.6.
3.6.
Yes.
So what is the answer?
The answer is 3.6.
So the answer is C. Okay. Okay. The progress.
Mm,
What will be the second order of this function? So the second differential. So the first one is negative 40 q, right? Plus
mm,
144. What will be the
mm.
second derivative? Shall be negative
That's
40.
negative 40. Yes.
So what's the answer?
Uh, so the answer is still B. How?
Yeah, the function is still maximum,
Yeah.
isn't it?
Yes.
Mhm. Now, evaluate this function at the critical value. What was the critical value?
The critical value is 3.6.
So let's evaluate. Negative 20,
Mm,
3.60 squared plus 144 multiplied by 3.6 minus 545.
okay. So this one would be, so it will be 3.6 squared times 20, which is
Mm-hmm.
259.
Negative 259. Mm-hmm.
259.2.
0.2.
So 4 times 3.6 plus 158.4.
158.
158.4 minus
No,
505.
no. 144 times the 3.6. It can be 158.
144 times 3.6. So,
Mm.
sorry, it's 518. Sorry.
Mm-hmm.
Yeah,
Minus 545.
5.4 minus 545.
Mm-hmm. Command
So,
your calculator.
yeah, negative 259.2 plus 518.4. That
Mm-hmm.
minus 545. 545. Negative 285.8.
Negative 285.8.
8. Mm.
So what is the answer?
Um, None of the above, is it?
Mm-hmm. Anyway, if that is what we have solved, that's
Too many none of the above.
oh, okay, interesting.
Yeah.
Giving you none of the above. Let's go ahead and do something else.
Mm.
Mm. The question number now is what? 10.
So, number 9?
Number 10. We
Number
were from
10.
number 9.
Okay.
Mm-hmm.
For the
The
following,
total cost function is q third minus 5q squared plus 66q. Okay. The critical
mm-hmm,
value of output at which the average cost function would be minimized.
mm-hmm,
Mm-hmm. How do you find it? So we need first of all to find the average function first because
mm-hmm,
we don't have. And the
mm-hmm.
average function I told you is total cost divided by what? By Q, isn't it? The output.
Okay.
That gives you the average. You remember?
Mm-hmm.
So you get the average, divide through by average so that it can be Q squared minus 5Q plus 66. This gives you the average cost function, isn't it?
Oh, okay. Yeah,
Now,
yes.
can you optimize the average cost function? Find the critical value of this. You differentiate it,
Mm-hmm.
right? Hope I'm not
Mm-hmm.
too fast.
No, no.
Can I
Rob,
go?
wait. Mm-hmm.
Right.
So, differentiating this one, let me try.
Mm-hmm.
Mm. Yeah, this one is 2q. 2q minus 5.
2Q minus 5. And
Yeah.
what is the critical value?
So the critical value should be 2.5 if I'm not mistaken. Just a minute.
And so what is
2.5.
the answer? What is the answer then?
The answer is 2.5. Oh,
Or
sorry.
D?
The answer is D.
Yeah. The question number now is 11.
Mm-hmm.
The average total cost function for the function would be, what would be the average total cost function for this function? So the average total cost function simply means that average function we found.
Mm-hmm.
How did we find this function? Oh, the average function was
Was
what was the average
2q.
function?
The average function is q squared minus 5q plus 66.
Exactly. Q
Mm.
squared minus 5q plus 66. This is the average. Now, the average of this evaluated at the critical value. The average total cost for this total function would be
So you
2.5.
you replace 2.5.
Mm-hmm.
Okay. So 2.5 squared is 5.
Mm-hmm. Are you sure? No.
2.5 squared is 6.25. Ah,
Mm-hmm.
how is sure?
Mm-hmm.
Okay. So minus 5 by 2.5, which is 12.5 plus 66.
Minus 12.5 plus 66. Uh-huh. Command your calculator.
5 minus 4.5 plus 66. 60.
It's a 60.
Yes.
Okay. So what is the answer? It's none of the above, yeah?
Mm-hmm.
D says the total cost would be, then now in this total cost function we replace.
Mm-hmm.
So it will be 2.5 cubed minus 5, 2.5 squared plus 66 times 2.5, yeah?
Mm-hmm.
Yeah. 2.5 cubed is what?
15.625.
15.625
Mm-hmm.
minus 2.5 squared, then times 5.
31.25.
66 times 2.5. 61 times 2.5. Hello? Are you logged out? Okay.
Yeah, so I managed to finish through the question.
Okay, so 66 times 2.5 is what?
It's 165.
165. So when you command your calculator, what do you find?
149.375.
149.375. Have you done the
Mhm.
right thing?
Mhm.
Okay.
Yes,
So what is the answer?
it's the D.
Okay. If that is what you are saying, we have heard.
Mhm.
Yeah. We will not argue with you. What was the ATC?
Sorry?
The ATC function.
It was Q squared.
Let's go back to 8.
Yeah, it was Q squared minus 5Q.
Just hold on this one.
Yeah.
Hold on a bit on question number 11. Just a minute, even less.
Mm-hmm.
Mm. Mm. Question number 11. What was the answer? We found the what?
That one. Let me just a minute.
So the average function, first we found the Q
Q squared
squared minus
minus
5Q plus
5Q
60.
plus 60. Yes.
And then we found the 2.5 squared minus 5 times the 2.5 plus 66.
Mm-hmm.
Can you command your calculator again?
The answer is 59.75.
Yeah, so the answer is D, right? Is it what we found?
Mm-hmm.
It's supposed to be D.
Yes.
Oh, okay.
Mm.
That was about the application of question number 1. Eh? That was question 1. This is now question 2. This is starting from question number 13. Sunday, so.